Dear viewers, I am back. I hope you subscribe to my channel, you like my videos and comment if you have any doubts, if you have any suggestions, if you have any opinions and all, you can comment down my video, and your support energizes me and my enthusiasm will lead to giving more knowledge to my viewers and enhancing them. So thank you for your support. I hope this support will continue forever. And thank you. So without much ado, let us go to the second part of ray optics, that will be refraction. Refraction. You know, this ray optics will take 2 or 3 videos to complete because very long chapter, but important chapter. Refraction. Refraction. First of all, you know that what is refraction. When light ray goes from one medium to another medium, the ray bends. The bending of the light ray when moving from a medium with refractive index mu1 to refractive index mu2 is known as what? Refraction. So this ray is bending. This is angle of incidence, this is angle of refraction. Okay. So from this we can find out something. What is mu? Mu is what? Refractive index. Okay, refractive. You know, this class aims to provide knowledge to the people who know the basics of the chapter. Okay, who know basics of the chapter. This is like a one shot video which you can see for revision, but never see this video first time to learn everything. Okay, this video don't have derivations, only small formulas and easy tricks are given in this video. So for more detailed one, please wait for some time. I don't think I'll be able to post it till January. After JEE Mains examination, we'll be thinking on posting on it for CBSE board examinations preferably. Okay, without talking much, let me conclude the same. So this is a mu1 having refractive index 1 and mu2. So bending of the light ray is known as refraction. From this image, can you find which mu is greater? Yes, mu2 is greater than mu1 because as if a velocity of light decrease in a medium, velocity of light decrease in a medium, then it will bend towards normal. So in this above figure, you look, this incident ray is coming and it is bending towards normal. So here mu2 is greater than mu1. You know, if speed decreases, refractive index mu increases. So very important formula or a relation. Speed V is inversely proportional to mu. Very important. Now let us move to a formula. Now to find a refractive index mu, there's a formula. It is C by V. C is speed of light in vacuum. And V is speed of light in medium. Speed of light in given medium. Please by heart this formula. Very important. Very important. Okay. So this is basics of refractive index. And now another thing I am telling, you know that V equal to F lambda from waves chapter, from sound chapter, etc. V equal to F lambda. Velocity is equal to frequency into lambda. In this equation, from one medium to another, F is constant. Frequency of light wave is always constant. So what changes is velocity changes and lambda, that is wavelength, also changes. Length changes. So you know that from this equation V equal to F lambda, this is like V equal to K lambda. F is constant. So V is directly proportional to lambda. So if speed increases, then wavelength of light increases. If speed decreases, wavelength of light decreases. So from air to water, in air wavelength is more, velocity is more. In water, wavelength of light is less, velocity is also less. This is very important relation. Now we'll be coming to Snell's law. One second, to take the same, I'll just copy this thing. In laws of refraction also the same plain thing is being told. Yes, we have here. We will take, yes, we have it here. Snell's law. What does Snell's law is telling is that sin I, that is sine of angle of incidence by sine of angle of refraction, is equal to mu 2 by mu 1, or refractive index of medium 2 with respect to 1. We can rearrange this and form an equation. Sin I, mu 1 sin I equal to mu 2 sin R. This will always be equal to a constant. So this is very important equation used everywhere in the following chapter. Very important. Now you know that refractive index is a pure ratio. It don't have a unit. Now we will be doing something. You know that sin I by sin R is equal to mu 2 with respect to 1. So mu 2 with respect to 1 can be also written as 1 by mu 1, refractive index of medium 1 with respect to 2. It's a reciprocal relationship. This is also important. Okay. Now refraction from denser to rarer medium. Look, I am very fast because I have to complete the same and do the questions from the same chapter. So that's very important. This chapter is theory based. Next one will be previous year questions. Okay. Now we have this thing, and angle of incidence, angle of reflection. You know that this is rarer and this is denser. That is mu 1 is less than mu 2. You know that if a ray goes from denser medium to rarer medium, it will be bending away from the normal because speed increases. Also wavelength of the light also increases. Now in the same case, at some, when we are putting this, when this incident ray is incident on the surface at a specific angle theta c, the refracted ray will be having an angle of refraction 90 degree. If angle of refraction is equal to 90 degree, then the corresponding angle of incidence, that is theta c, this is called as critical angle. It's a very critical angle because when R is having, if the angle of refraction is 90 degree, then the angle of incidence which gave this 90 degree of refraction is called critical angle. How to get this critical angle? How to get the value of this critical angle? Look, first of all, I am going to consider this medium to be air. So I am giving refractive index 1 to the medium 2. Now here it is critical angle because it is having this is critical angle because it's having 90 degree refraction angle. So I can write from here sin theta c, that is Snell's law, sin theta c by sin r equal to 1 by mu 1, right? So therefore theta sin r is how much? Sin 90 degree, that is 1 by mu 1. Therefore I can write sin theta c, that is sine of the critical angle, is equal to 1 by mu 1 or just mu, because it is the refractive index of the denser medium. That's it. 1 by mu. Very important relation. Please start. Okay. Yes. Next, this is coming to an end. This is what about critical angle. If what happens if theta, if angle of incidence greater than critical angle, there happens the for the phenomenon of total internal reflection. If I is greater than theta c, then the incident ray will not refract, it will reflect inside the medium. This is known as total internal reflection. Okay, very important. This is the reason for the sparkling of diamond. Okay, now we have another important topic, that is refraction through the slab. I'll just draw one picture. This is a glass slab. Yes. Now a ray is incident on it. One second, I'll draw the same and I'll repause the video. Yes. Look, this is angle of incident, this is angle of refraction, this is also angle of refraction, and this is angle of incident. They are the same. You know that always there will be a lateral shift. Okay, because the angle of deviation here is 0 degree, but there is lateral shift. Lateral shift means displacement of the refracted ray. Okay, lateral shift. The formula for the lateral shift is this is lateral shift simple, or we'll give this thing is equal to sine I minus r by t by cos r, where t is the thickness of the slab. Very important formula. I'm just giving this formula, very important. Just learn it. Now we'll be having longitudinal shift. It's an important topic. Longitudinal shift. You know that the bird water problem, and you have heard a lot about the bird water problem, bird coin problem, bird fish problem, etc. from ray optics. This all depends on this lateral shift. Look, there is a tumbler. It's full of water. And one second. Okay. One second. Yes. It is full of water. Now there is some object here, and a ray from that object is coming outside, and it is getting refracted from denser to rarer medium, so away from the normal. Yes. Now ice is here, one person is looking in. Now one more ray will take. This is like this, it's coming, and it is away from the normal. Now we'll we'll extend this to, and we attach it. Look, this thing is erased. This thing, originally the position of the image is, actual depth of the image is d, but there is an apparent shift, that is delta, and now the new depth is apparent depth. Really the object is seen to be raised, right? So there's an apparent depth. So the formula for this apparent depth is h apparent equal to h actual by refractive index of this medium, because this is, outside it is air, inside it is mu, right? So refractive index mu. Very important. Okay. Now, if the condition was, okay, this is the formula, refractive index U. If the condition was really opposite, that is a person is inside the water, ice is here inside the water, and he is looking at something in the sky, and what two ray from the sky is coming towards his eye, and he is seeing the image somewhere yes, he's seeing the image somewhere above the original body. That is, this is some shift is happening. The original depth is actual height is this. Now the height is being increased. Now the apparent height is greater. The height. Now what is happening? Yes, apparent height is this. Now what will be the H apparent? It is the opposite formula, that it was H actual by mu, because here apparent height is less than actual height, so we will divide it by mu. Here apparent height is more than actual height, greater, so we will multiply it with mu, actual height with mu, so we get the apparent height. These two formulas are really important. Okay, yes. Now I am talking about apparent shift through a glass slab. There is an ice here, and there is an object somewhere here. So there's an object. When I am seeing through this glass, the object seem to be here. Apparent. Really the object is here, that is actual, but apparently it is being lowered, or it is seen to be near. So there is a lateral shift, or there is a shift. So this shift can be calculated from the formula T equal to 1 by mu, where mu is the refractive index of glass. Very important. T equal to T into 1 minus 1 by mu. Okay, very important. So these are the formulas for longitudinal shift. Okay, so I think in the next class I will be dealing with prism and all. Because there is a lot in prism to talk about. And after that, there will be a fourth part for lenses and a fifth part for optical instruments. So in 5 parts, I will complete this chapter. So thank you for watching the video. Thank you. Please like, share and subscribe and encourage me. Okay, thank you.